myself is S.SURESH working as assistant professor in Electronics and Communication Engineering, PSN College of Engineering and Technology. So today we are going to discuss about the control system and its applications. So initially we need to understand the concept of system. First of all, we need to understand the concept of system and introduction about the control system. After that, we have to understand the concept of example of the control system and open loop control systems, closed loop control system, block diagram of control system, and signal flow graph. So these are the topics we are going to discuss about in this subject or topic. So initially, the system is the definition. So when a number of elements or components are connected in a sequence to perform a specific function is called as a system. So this is the definition of the system. So initially we need to understand the concept of the system. So system is the number of elements. The element having more number of element or components are connected in a sequence to perform a specific function. For example, here we are going to do some specific work that is called a petrol filling and a traffic light control system. So such kind of some applications, that is called specific applications, we are going to implement in this system. So it is called as a system. Okay, so the next one, control system. So in a system, when the output quantity is controlled by varying the input quantity, so the system is called as control system. So control means here we are going to controlling the output quantity by using input quantity. So whenever we are having, we are going to give the input to the system, the input is going to change with respect to the output. Okay, so this is called as a control system. Next one, examples of control system. So here there are various examples are available. So for example, first one, temperature control system. Here we are going to monitor the temperature of the system. And traffic control system. So in traffic control system we are going to use different colors. For red for stop, green color for go, yellow color for ready. So these are the different control systems are available in the traffic. Okay, similarly numerical control system and position control system using servo motors. So these are the examples of control systems. And next we will discuss about the types of control systems. So first one, there are two types of control system. First one, open loop control system and closed loop control system. So these are the different types of control systems. And first we'll discuss about open loop system. So this is the definition and the block diagram of open loop system. So initially we'll discuss about the open loop system. So any physical system which does not automatically correct the variation in its output is called as open loop system. So this is the definition. So it is the physical system which does not automatically correct the variation. So it is not correct the output variation automatically. So this is the drawback. So that here we are not using for particular specific applications. The output is not feedback to the input for corrections. So this is also one of the major drawback in open loop system. There is no feedback at all. So we see the diagram of the open loop system. Input of the system is R of t and output of the system is C of t. So input is going to the system. So the system will not having any kind of feedback. Without feedback, the output is going to produce. So the output depends on only input, but it is not feedback to the input, and also the output is not corrected automatically by using any kind of input changes. So for example, environmental changes in input, the output is not able to corrected automatically. So this is one of the drawback in open loop system. Okay. And advantages of open loop system. So there are various advantages, like it is a simple system and it is economical, means it is a cost wise is very less, that is called as a economical, is very simple and easy to construction. So construction of the open loop system is very simple because there is no feedback, so we are not having to add external components along with the system. That is called as a easy to construct the open loop system. And the open loop system is very simple and stable system. So stable means what? So the concept of the stable means without having any interrupt. So that is called as stable. Okay, if the interrupt will be increasing, then the stability will be changed. System stability will be changed. Okay, and the disadvantages of open loop system is inaccurate and unreliable. The changes in output due to external disturbance are not corrected automatically. So these are the disadvantages of open loop system. So after the completion of advantages and disadvantages, we will be discuss about the closed loop system. So this is the definition of closed loop system. So closed loop system in which the output has an effect upon the input quantity in order to maintain the desired output value are called closed loop system. So this is the definition and the block diagram of closed loop system. So we have to find out the output has effect upon the input quantity. In order to maintain the desired output, we need some standard and a particular output. We need to decide the output value with respect to the input value. So we need to change the input, and also we have to get the output efficiency will be more with respect to input. So you see that the block diagram of closed loop system. So it having the input R of t, that is called as a reference input, and output having C of t, that is called as a controlled output, that is called C of t. So these are the different blocks which is using in the closed loop control system. Okay, so there are various blocks. First one error control detection, second one controller, third one open loop system, fourth one feedback. These main four blocks are used for block diagram of closed loop system. Okay, so error detection, it is the difference between feedback signal and reference input, and the output of the error signal is given to the input of the controller, and the controller is given to the open loop system. Input of the open loop system, then output of the open loop system is partially is taking to the error detector by using feedback system. So the feedback is available in closed loop system, so the system efficiency will be increased compared to the open loop system. The block diagram consists of the following components. So the block diagram of the closed loop system consists of the following components. First one error detection, second one controller, third one plant, that is called open loop system, fourth one feedback path. So the reference signal, that is called input signal, or it is represented by R of t, is corresponding to the desired output. The feedback path element samples the output and convert into a signal of same type as that of reference signal. So here R of t is called as reference signal or input signal, which is corresponding to the desired output, means constant output we are going to perform. So we need 90% of the output. So we need to edit or change the system plant concept, and we have to get the 90% output. So this is the desired output we are going to get with respect to different input signals. And the feedback path is going to refer the samples of the output and convert it into signal. So output is feedback to the input. So here output is the sample of the output is converted into input. So the difference between reference signal and feedback signal, this is called as a error signal, that is called error signal. The feedback signal is proportional to the output signal and fed to the error detector. So error detector or error signal, so this is the difference between reference signal and feedback signal. So this is the main concept of error between feedback and reference signals. The error signals generated by the error detector is difference between reference signal and feedback signal. This only we informed now itself. So the controller modified and amplifies the error signal to produce better control action. So controller is the input is received from the error detector, and the controller, it will be control, or it having the modify the process of what kind of process they are doing. It may be a temperature, or it may be a servo motor control, or it may be a traffic light control. So what are the controller type of system is modify and amplify the signal. So the amplify the error signal and produce the better control action in the output of controller. So output of the controller is depend on the error signal amplification process. Okay, so what are the error is available, then it will be rectified by using controller. Then the modified error signal and feed to the planter to the correct its output. So here the modified error signal, so output from the controller, it is the modified error signal is given to the open loop system plant to correct its output. So these are the process of block diagram in closed loop system. So next we will discuss about the advantages of closed loop system and the disadvantages of closed loop system. So it is accurate and it is less affected by the noise. So we know that it is an accurate system due to the feedback is available, and it is the noise will be very less because there is no any kind of distortion. The less noise will be produced compared to open loop system. In open loop system there is a more noise because in environmental changes then the output will be inaccurate for open loop system, but in closed loop system it is accurate and less affected by the noise, and sensitivity may be made small to make the system more stable. So depends on the sensitivity of the system, it will be more stable. The system will be stable with respect to sensitivity is high. And disadvantages of closed loop system, it is the high complex system. Means what the construction of the closed loop system is more components, so the system complex is a system, and the high cost of the closed loop system is very high because it is representing more process, initial process, output process, feedback process, and error control and rectifying the error control. So the process will be very complex and high cost. The feedback reduces the overall gain of the system. So maybe the feedback which is possible to reduce the overall gain of the system. So gain of the control system will be reduced maybe by using the feedback system. Next we will discuss about the next topic in control system, block diagram. It is one of the important topics in control system. So first of all we will discuss about the introduction of block diagram. A block diagram of the system is a pictorial representation of the function it performed by each component and of the flow of signals. So here the system which is represented in the form of pictorial representation of the functions which is performed by each component. So each component having pictorial representation by using the various systems. Okay. And the flow of signals also it is available from the input to output. And the elements of the block diagrams are block, branching point and summing point. These are the three elements which is used in the block diagram for reduction method. Next one, first element is called as block. So now we'll discuss about first element. In a block diagram, all system variables are linked to each other through functional block. So each and every process will be representing or working with respect to the functional block. The functional block is represented by transfer function g of s. Okay, so this is called as functional block of the system, and the diagram of the functional block is represented by g of s. Input is a and output is b. The output is equal to product of input and system g of s. Input is a, output is g of s. Then the functional block, or simply a block, is a symbol for mathematical operations on this input signal to the block that produce the output. The output B is equal to product of input with the system G of S. So this is called as functional block diagram of control system. Block diagram. Next, second element is summing point. The summing point is the second element of the block diagram. It is used to add two or more signals in the system. See the diagram for representation of summing point. A is one of the input signal, B is one of the another input signal. So here we are going to use two input signal going to add. Okay, so A is positive and B is negative from the representation of summing point. So the difference or summing of these two signals, which is represented by A minus B. So this is the second element of summing point. Next one, branching point of the block diagram. So it is the third element of block diagram representation. So a branching point is a point from which the signal from a block goes concurrently to other blocks or summing point. So other blocks are summing point. So the representation of branching point diagram is given in the shown in here, and the G is representing for the system. Okay, so before the system we are having one point. The point is called as branching point. Okay, the branching point is going to after the block of the G. Okay, and the B is called as output of the block. So B is equal to A into G. A means input, G means G gain of the system. So next we will discuss about the rules of block diagram reduction. So there are different various rules available in the block diagram reduction method. So first one, rule 1. So rule 1, which is going to implement combining the blocks in cascade. So cascade means series combination of blocks. So blocks means system G1, G2, like that different blocks are available in the block diagram method. So we are going to combine, or we are going to add all the blocks in cascade or series combination. Second rule, which is going to combine the parallel blocks. So instead of series will be cascade, and here the rule number 2 is representing for parallel block we are going to combine. So parallel block means G1, G2. These two blocks are combined with the parallel combination. And the next rule 3 is going to implement for moving the branching point. Now we discuss about the third element of the block diagram, branching point. So the branching point is going to move after the block, that is called ahead of the block. Okay, this is called as rule 3. And rule 4, we are going to use the moving the branching point before the block. So branching point before the block G we are going to move. So these are the some moving of branching point from after the block and before the block. Okay, then rule 5, moving the summing point after the block or ahead the block. So similarly like a branching point also we are moving after the block and before the block for rule number 3 and 4. Similarly rule number 5 is going to use to move the summing point after the block, and also rule number 6 is going to use for moving the summing point for before the block. Okay, then rule number 7, it is going to implement the interchanging of summing points. So we are having the summing point there are 4 possible values, it may be positive or negative. So we can able to interchange the summing point. Similarly, the rule number 8 is going to splitting the summing point. So split means we are going to dividing the summing point from each devices of the system. And rule number 9 is going to combining the summing point. So rule number is combining there are 2 summing point is available. We can able to combine for different values into single values. So rule number 10 is called as elimination of negative feedback loop. So feedback loop we are going to eliminating. For that we are having some kind of standard equations to reduce the negative feedback loop. Similarly, rule number 11 is going to elimination of positive feedback loop. So positive feedback and negative feedback, both we are going to eliminate with the rules 10 and 11. So these are the different rules which is using for the block diagram reduction method in control system. So it is one of the important topic for reduction of block diagram method. So now we have to explain or expand the rule number 1 for each and every concept with the formulas. Combining the blocks in cascade. This is the rule number 1. So here A is called the input of the system, and G1, G2 are each blocks, block 1 and block 2 respectively, and the output of G1 block is A into G1, and the output of G2 is equal to A into G1 into G2. So this is the initial stage of blocks. After we are going to combining the blocks in cascade. So we are using the product of the each block into single block. Okay, so A with G1 and G2. So these are we are going to combine. So the output of the block which is going to combining the blocks in cascade. So cascade means the product of A into G1 into G2. This is the combining output of the blocks in cascade. So this is the concept of rule 1. Similarly, we'll find out the combining the blocks in parallel blocks. So that is called rule number 2. Here G1, G2 are two blocks are available. A is going to input of G1 and also G2. So the output of G1 is equal to A into G1. Similarly, output of G2 is equal to A into G2. Then we are going to combining the parallel terms by using summing point. Already we discussed in the elements of summing point. So it is one of the element. So we are going to combining the two blocks in summing point. So the output of the summing point is equal to A into G1 plus A into G2, which is equal to A is common term and combining G1 plus G2. So this is going to combining in terms of single block. So we instead of 3 blocks we are using G1 block, G2 block and summing point. So instead of these 3 blocks is going to combining a single block with input A and output is equal to A into G1 plus G2. So this is the combining parallel blocks in block diagram reduction method. Next one, rule number 3 is going to moving the branching point. That is called after the block we are going to moving the branching point. So we know that A is the input and G is the block of the system, and before the G we are having a moving point. So that is called a summing point. The summing point is available. We need to shift or move the branching point is into after the block. So that is representing we are going to use the formula for A into G, and A into G divided by 1 divided by G in that is equal to A. So that we will be get the same output what is the representing the LHS equal to RHS process. So what are the LHS means left hand side the process is equal to right hand side process. So this the moving the branching point after the block. Clear? Similarly, in rule number 4 we are going to use for moving the branching point before the block. We will discuss now. So see the diagram for moving the branching point before the block. So before the block. So before the block means G is the block. So A is the input. Before G we are going to move or shift the branching point. Then we will get the output will be A into G for both the outputs. So this is the rule number 4 in the block diagram reduction method. Next, rule number 5 we are going to discuss about moving the summing point after the block. So summing point we are going to after the block we are going to move it. Okay, so A is the input and B is the input of the summing point. The output of the summing point is called as A plus B. The A plus B is going to move after the G, that is called after the block G. Okay, so the right hand side is representing the after the summing point is moved. Therefore, the output of the summing point is equal to AG plus BG is equal to A plus B into G. So this is the rule number 5. Similarly, moving the summing point before the block, it is called as a rule number 6. So already the summing point is available in the after the block. We are going to move or shift the summing point before the block. Then the input A and B is going to change 1 divided by G. That is called B divided by G. Then the summing point output is equal to A plus B divided by G. Then the input of the value is equal to A plus B divided by G, and the output of the G is equal to A G plus B. By using LCM, we have to take the output by for the gain block output. Next, rule number 7 we are going to discuss about. So interchanging the summing points. Already we know about there are two summing points are available. We need to interchange the summing point with respect to the same value of the output. So output should not able to change, but we are going to interchange the summing point. So for example, A is called input, B is called the input of the first summing point. Similarly, second summing point having A plus B and C are the inputs. The total output is equal to A plus B minus C. We need the A plus B minus C. After interchanging the summing point, the same output we will get A plus B minus C. So here right hand side A and C are input of first summing point, and A minus C and B are summing of second summing point of second summing point, input of second summing point. Then total output is equal to A plus B minus C. So both cases will be common for interchanging of summing point. The output will be same after interchanging the summing point. So this is the rule number 7. Next, rule number 8. Splitting summing points. So here we are going to splitting the summing point A, B, C. These three inputs are going to combine into a single output. So A plus B minus C. These three inputs are combined into a single output. So here we are going to splitting the summing point. For two summing point we are going to use. So there's two summing point we are going to use. One will be AB for first summing point and second summing. So we have to discuss about the rule number 9. So for combining the summing point, so we are having two summing points, so we need to combine into a single summing point. So two summing point, first summing point having A and B input, and the output of first summing point is equal to A plus B, and the second summing point having two input A plus B and AC, and the second summing point output is equal to A plus B minus C. So the total system which is going to combine, or total elements which is going to combine into a single summing point for A, B, C, all three together combined into a single summing point. The output is equal to A plus B minus C. So this is the combining of summing point. Rule number 9. So next we will discuss about rule number 10. The eliminating of negative feedback loops. This is the rule number 10. So here we are going to eliminating the negative feedback. So we are going to reducing the negative feedback. So here R is called input, C is called output, and there are three components: summing point, plant system, open loop system, plant G and H. These three elements are in the system. And here R minus C H, it is called the output of the summing point, and R minus C H into G is the output of the plant, and C is the output, and C is feedback to the H feedback. H is called the feedback, and the output of the H feedback is equal to C into H. Then the difference between R and CH is called the output of error signal R minus CH. So these three elements, first element summing point, second element G block, third element feedback H. So these three elements are combined into a single element by using this proof. So that is called the elimination of the negative feedback loop. So C is equal to R minus CH into G. So here we are going to multiply the G inside of the element. So R into G minus C H into G. So here C we are going to take into the output in one side and the remaining term is the other side. So C plus CHG is equal to R into G. So here C will be common in left hand side. So we are taking 1 plus GH. So then is equal to in right hand side R into G. So we are going to find out C divided by R. So C means output, R means input. So output by input is equal to the system output will be G divided by 1 plus GH. So that only we drawn in the right hand side diagram. So R is called input, that is called reference signal, and C is called output, that is called the desired output, and G by 1 plus GH is the elimination of negative feedback loop block. So this is the concept of rule number 10. Next, rule number 11 we are going to use for elimination of positive feedback loop. So here instead of negative feedback also, here we are using the positive feedback we are going to eliminate. So in the summing point we are having minus for negative feedback loop, and in the positive feedback loop we are having the summing point. Both the input of summing point is positive. R and H both are positive, and G and C we are taking C is equal to output of G into so difference between the error signal. So here this is also we are going to use the same process for what we done in the negative feedback. C is equal to R minus, instead of minus we are going to use plus CH into G. So C is equal to R G plus CHG. So that is called the elimination of positive feedback, and C plus we are going to use for minus CHG is equal to RG, and C is the common term. Then instead of 1 plus for negative feedback, here we are using for positive feedback 1 minus GH is equal to RG, and the total output C by R is equal to total output divided by input C by R is equal to G divided by 1 minus GH for elimination of positive feedback. So this is the concept of positive feedback elimination and negative feedback elimination. So these are the rules which is used for block diagram reduction method. Next we are going to see one of the example for block diagram reductions. By using these rules we have to apply in this example. So example 1, that is called reduce the block diagram shown in the below figure and find the transfer function C by R. C means output, R means input. So this is the diagram which is given. G1, G2, G3 are blocks. Okay, and there are two summing point and only one feedback available in G1 block. Near the G1 block only one feedback. So this is the given example. By using this, by using these rules, we are going to reduce the each and every blocks. So first step we are going to use move the branching point after the G1 block. So already before the question before the G1 block one summing point, or take up point available. So we are going to move the branching point after the G1 block. Then we have to use the rules of moving the branching point after the G1. Then we'll get the second step for after moving. We will be multiply 1 divided by G1 and G3, and the denominator value will be different values. And eliminate the feedback path combining 1 by G1 and G3. See the top one, it having feedback having one block and a cascade of 1 by G1 and G3 blocks. There are two blocks are cascaded, and we are using for negative feedback loop to eliminating the input side. That is called R is the input. Okay, so this is step number 2. Here we are using two rules. First one rule is feedback elimination of negative feedback loop, and the second rule which is used for cascading means cascading of two blocks. So this is the G1 divided by 1 plus G1H. This is the elimination of negative feedback loop. And next we are going to combining the parallel block G3 divided by G1 and G2. So these two are in the parallel. We are going to add. Okay, so add means sum of two blocks, G1 block with G3 by G1 block. So the total output C is equal to, we are going to reduce the block in parallel. Then the step number 4, combining the two blocks. First block is the G1 divided by 1 plus G1H, and the second block is G2 plus G3 by G1. So these two blocks are in cascade. So we are going to add, the total output is equal to, we are going to find out, cascade means product. So parallel means addition. Clear? So addition means G2 block is summing with G3 by G1. This is parallel. And G1 divided by 1 plus G1H and G2 plus G3 by G1. This is cascade, means product of these two blocks. Here we are going to simplify the expression for transfer function C by R is given by E is equal to G1 divided by 1 plus G1H and G2 plus G3 by G1. So here we are going to multiply this expression and simplify by using LCM, taking LCM of G1 and G1 G2 plus G3 is the numerator, and we are going to cancel the numerator G1 and the denominator G1, and the value of numerator G1 G2 plus G3 divided by denominator value is 1 plus G1 and H. So this is the overall transfer function of the system. So this is the example we are going to find out. We have completed in the transfer function for this diagram. So this is the block diagram reduction method. Thank you for your kind information.